All right. So, I don't need that. I know, but I'm going to do it again because it won't hurt you to pay attention the second time. So if you've already filled this out, just listen. Okay. So I've got two graphs here. X minus 4 equals, or 4y equals 4, and then we have 2x minus 3y equals negative 3. So my first question, raise your hand, and remember I'm recording, so let's not blurt out any names. I'll point to you. I'm going to ask questions, you raise your hand, and I'll point to you, and then you answer the question. Which one of these equations should I solve for one variable? Raise your hand. Yes. The first one. That is correct. We want to solve the first one. Now, here's the next question. Are you ready? Do I not look good with this new haircut? Raise your hand. No? All right. Yes. Yes. I got a thumbs up. So anyways, no, the serious question is, why did we pick the first equation? Raise your hand. Yes? Yeah, the x has a coefficient of 1, which is a fancy math way of saying it's easy to solve for x. So what am I going to do next? Raise your hand if you think you know what we got to do to solve for x. Yes. Well, yeah, but we got a minus 4. So when you minus a minus, what is that? Yeah, we're going to do a plus 4 because I want these two to add up to 0. But, like you said, whatever we do on one side, we have to do together. Can I add 4y plus 4? Yes or no? No. Why do you think no? Yeah, what's the fancy math way? Do you have rocks in your mouth? What are you doing? Oh, you have ice in your mouth. Okay. So the 4y is not a like term with 4. What she said was, all right. So now part of this process, this is what confuses people. And I'm going to explain it a little bit. When each one of these lines represents the graph. The x and y value are the same for both equations where they intersect. So we make the assumption that the x value for one equation is the same x value for the other equation if they intersect. And if that's true, then I get a bunch of numbers and a variable, and I can solve. Same with the y. The y value is the same at the intersection for both equations. Under that assumption, I'm going to take this x equals 4y plus 4 and plug that into the second equation. So my second equation is 2 times x minus 3y is equal to negative 3. But instead of, because it says right here, it says 2x, right? But instead of plugging in x, x equals 4y plus 4. So I'm going to say, all right, well, let's just do this. I'm going to substitute in 4y plus 4. Now what do I do? Raise your hand if you know. Yes. Yeah. You're going to push the 2 through the parentheses. So I'm going to, but before I do that, let me back up and ask you another question. What do you notice about this? What did we do by substituting that x value in with y values? I've got some numbers and y's. If I have one variable and a bunch of numbers, can I make it look like y equals some stuff? Yeah. So, yep, she's right. Let's distribute through. What's 2 times 4y? 8y. What's 2 times 4? Positive 4. Why do positive 8. You said 8, I said positive 4, but what I meant to say was positive 8. Why is Mr. Adams calling it a positive 8? Are you saying that I don't know how to draw y's? Okay. All right, so now I have some like terms. What's 8 minus 3? So that becomes 5y plus 8 equals negative 3. I'm going to subtract. Wait a second. Yeah, oh, that's right. This was the one that had like the weird numbers, right? So now when I subtract 8 from both sides, I get 5y is equal to negative 11 over 5. Y equals negative 11 over 5. So now to find the x value, I'm going to take this equation right here, this thing, and I'm going to say x is equal to 4 times y, which is negative 11 over 5, plus 4. Wait, yeah. I'm writing this down kind of wonky, but how do I make 4 over 1 have the same denominator as 5? Yeah, I'm going to multiply this by 5. Whatever I do on the bottom, I have to do to the top. So now for this one, 4 times negative 11 is negative 44 over 5 plus, what's 4 times 5? 20 over 5. When I add those together, don't I get negative 24 over 5? Now, what's interesting is I got to convert that to almost like a decimal. So let's convert these fractions to decimal just to kind of see where we're at. So if I plug in my handy-dandy calculator, if I say negative 11 divided by 5, I get negative 2.2. So y equals negative 2.2. Is that what we had yesterday? Well, yeah, whatever. So now the next, yes or no, was it what we had? Yeah, and then we have negative 24 divided by 5. Negative 4.8. So that means x equals negative 4.8. And so this point right here should be negative 4.8, comma, negative 2.2. That's kind of hard to see, but that's a 2. Well, now I messed it up completely. Negative 2.2. Now, how could I double check that? I'm just going to plug the original equations in the decimals. So the first one was x minus 4y equals 4. So we'll say x minus 4y equals 4. So far, so good. Then the other one was 2x minus 3y equals negative 3. So 2x minus 3y equals negative 3. Was that right? Oh, yeah, 3y. I meant to hit y. Hey, what do you see there? That looks pretty good, right? I'm going to take a screenshot of that. So, was our math right? Well, duh. Yeah, because you guys have an amazing math. Thank you. Exactly. Listen, just because I'm re-recording this video doesn't mean that I'm not a brilliant math teacher. It just means I'm a human being and I make mistakes. All right, do you guys see that? Or maybe I'll put it up here so it's a little bigger. Does that make sense? Okay, cool. That's it on that one. So I'll leave that up there for a second so you guys can